x. Okay, now you can close your braces, which means we have given a if and a else. Now you can type your value of x. It tells you very clearly, yes, of course, x is greater than 2. Because x value of x is, if you want, you can also check the value of it's 4. So it is greater than 2, which means that y is x plus 10, which is 4 plus 10, which gives you 14. Okay. So now we'll get with the second program, repetition using your for loop. Okay. So let me give you the value of x. Okay, x is assigned some vector. Vector has to be given in the form of c of. Okay, so let me start from here and end with 19. Okay, so if you want, you can see the value of x. It comes from 5 to 19. Okay, so let me now start your for loop. For, okay, you this is like somewhere will be similar to that of your Python in. Okay, so when it starts from here until from 1 until length of x. The length of x here becomes your 15 numbers. So, okay, so until 1 until next. Okay, what is it supposed to do? So before that, you have to open your brace. So don't close it off. Give it to the come to the next only. Then it comes to the next one. Okay. So what does it ask to do? We are supposed to add y along with your x plus 2. But each time when it adds, it has to be given a number. So x of I should be assigned, sorry, y of I should be assigned x of I plus 2. Okay, so do you have anything else to be written? No, I can just close it off. Okay, now let me give the value of y. Okay, can you see? So each time it is added by 2, it checks from I should be from 1 to 15. That is the length alone it sees into consideration. So indexing is here. We are doing the indexing format. So here we are doing with your indexing format. Indexing is nothing but your x has been added with 2. So 5 plus 2 is 7, 6 plus 2 is 8, 7 plus 2 is 19. So it goes on from 19 plus 2 is 21. Okay, so this is your usage of your for loop. You can also try your right side program. I'm doing one for you. You can try the next one. Okay. So now we'll use your while construct. While consists of only one conditioning. Okay, 1 minute, 1 minute. Give me 1 minute.
Hello, ma'am.
So 1 minute, I'll come now.
Okay, no problem. Why? Because
So sorry, everybody. It was a call from a college, so I couldn't avoid it. Okay, sorry, really sorry. Okay, so now like we'll go with your while loop. While is nothing but it is a repetition loop. While expression one, we'll be doing something only. Okay, it'll make a condition of only one thing. It will be making it. Okay, so usually if it is perfect, you can leave it off. If you are checking something like greater than something, and if it is not perfectly a value, and if you have a constraint of a huge number of vectors and everything, you have to use your break. Okay, so let's do this now. Okay, now we'll do it. So we have already x value. Okay, so let me use the same x value. So x has been available over here. Okay, x is available. So we'll use now while. What is here while? Whenever x is found to be greater than 10. Whenever, see here. So mean of x is greater than 10. Okay, so it is only checking one value, so it is taking only the mean. Okay, mean of x greater than 10. Whenever it is greater than 10, what are you supposed to do? Don't close it off, just come okay, I have not given you the open brace. Okay, so whenever your mean is found to be greater than 10, okay, now this is okay. So now what are you supposed to do? What are you supposed to do? Either you have to add your y with x plus 2. Okay, whenever it is found to be, whenever the mean of x is greater than 10, you have to do it. Okay, so now like y is greater than, y should be added with 2 with your x. So x plus 2. Okay, now I can close it off. That's all. But sometimes what happens is it will be just running out. Let's see. Okay, so y, sorry. Okay, so y value comes automatically as 7, 8, 9, 10. Okay, it is your ordinary y. Okay, 1 minute. I'll once more run because I have come out of it. Okay, y. So now like okay, x plus 2 and close your brace. Okay, once you close it, you can come out. Okay, enter, and you have to wait. Okay, wait. It will run. So now let me give you the value of y. It comes as 7, 8, 9, 10. Okay. Okay. So while is completed, you can also use your repeat function, but every repeat should have a break. Okay, let me do that. So give the value of x. Let me have the value of x as 10 and the value of I should be assigned as 1. Okay, and then we'll start with your repeat. Repeat off. So don't close it off. What is our repeat? It tells you that each time I should be greater than, repetition should happen, I plus 1. Okay, and y should be like x plus I. Okay, so whenever your I crosses greater than 30, it should break out and come out. Okay, that is your condition. Okay, so now like I is equal to, I is always I plus 1. Okay, and my y should be, and my okay, either you can use equal to also. Okay. Say x plus I. Okay, so here I'm finishing it off. Sorry, I'm using the next condition. If my y is greater than, that's how we are using, right? Sorry, I is greater than 30. Okay, so that's your repetition iterations. So whenever your I is greater than 30, you can use your now your open brace over here. Okay, and don't close it. So come to the next line. We'll close one by one, but before that, it will again and again go. So you require a break. So now close your braces. Again, one more brace is there, and you can come out. Okay, you have come out. Now let's check the value of y. It is 41. Can you see? Okay, repetition happens. Repeat alone is also you can use. provided instead of I from a for loop automatically takes, here you have to give your iteration from I is equal to I plus 1. Okay. And we'll see the basics of functions which has been used over here, very basics of functions. Okay. I have the coding with me. I'll use it. I'll send 2 files today. One is your coding file. Along with that, I'll also send your the notepad. Okay. Presentation as well as the codes. I'll send it. That will be easy for you to note it down. Okay. See here. So what am I doing is I'm using a function. Okay. Okay. Better is I'll type it down. Then it will be easy for you to understand. So I'm using my, you can find here how to use your functions. So you have to give a name, and within the name should be assigned, that is the name of the function, or it has been assigned to a value. So function of, you have to pass your arguments, A1, A2, whatever variables you'll be using inside your function has to be passed by means of your function of. This is the keyword function of, okay? So function is, should be, how many ever variables you'll be using, A1, A2, everything, and inside that there will be a body, okay? So down you can see where name is the function name, and your A1, A2 are the argument list, and body is the function body, which is a collection of valid statements and expressions. And last line should also again, you have to use your open brace and your close brace, okay? You can use anything can be used. Here we are using the functions as n, comma, mu, comma, sig, sigma, okay? So I'm also using the same for your better understanding, so that will be easy for you to. So now this is what is my name, which I'm using. This is my function name, and I'm using the keyword function of. Now I'm passing the argument n, comma, mu, comma, sig. Okay, this is that I'm passing. So once you open your function, it should have a open brace, right? There should not be a closed brace. There should be a open brace. So open brace is there, right? So inside that you can just give an enter. Once you give an enter, it will be entering inside. So once you enter inside, you can find that you can type it. Okay. So now I'm taking the value of x. The value of x is found in the form of, I'm taking a random variable. Random is rdim. Okay. To take a okay, you can give a random variable of x. Okay. Or nominal of, you're using your nominal. Okay. So n is equal to mu, comma, sig. Okay, so we'll see this, what is R norm. This all we'll see in probability. I'll show you. Okay, don't worry about it. We'll show in probability. So this is your random, nominal random. Okay, and then we'll use your D norm. Okay, for Y, which is your I'm passing the value the same, but provided significance. SIN is your significance. Okay. Y x I have used a nominal value of n, comma, mu, comma, sg, and here I'm using x, comma, y, comma, and everything. This has been stored in x and y. So what I'm doing is I'm doing a plot also. So plot gives you the plot between x, comma, y. Okay. So after this I can finish it off. Okay. Once I finish it, I can come out. Now I can give function, right? I can give you the value 1000, number n is 1000, and your value is 10, comma 5. Okay, my significance level is 5%. Okay, okay, I have given instead of sorry, instead of n, I have given it as, okay. So let me see here once more. So here I have used sorry, it should be n. There is a mistake what has been done. So plot of, okay. So now I'm passing the value. This is the function name. So I'm passing the values. I'm passing 1000 for n, and mu is 5, and your sorry 10, and your significance level is 5. Can you see? Okay, so functions, it calls any variable when it gives out. So let me show you. See here, it shows the mean of your normal distribution is 10, and it has been distributed from 5 to 25 because I have given the number from 1000, which means like 1000 points have been taken, and all those. Okay, so now like let me show you in this perfect. If you want your your mu is nothing but your mean. Okay, so mean has to be, I want my mean to be 0, passing, and my significance to be 1. You can find here, see. So you can you find here, you know, your mean has found to be 0. Okay, so plotting, you can give your values. Once you pass your value, you can find how your data have been normally distributed. So these are the macros which we have yesterday missed out. Okay, and yesterday the next topic which was left out for the day yesterday was plotting. Okay, plots. So how, let's see how to do plots, and then we'll get into modeling. So today's class will be modeling. So these are the portions which was left for yesterday. So we'll see the modeling next one. So first I'll finish with your so univariate plots. So we'll see what is plot. So plots can be of two types. Okay, let me show you. So plots can be of two types. You can use plot of, okay, plot of x comma y. We have various x and y here and there. You can find that there is no value which has been assigned. So okay, what is x? Okay, what is y? Okay, so it makes a point over there. Can you see? There is only a dot. Okay, so this is the normal way of doing a plotting, where this does not look so good when it comes to doing your journals, writing a journal and everything. Your plotting will be very nominal, very normal one. So to make it very colorful, we have something known as GG plot, which tells us as grammar, grammar of graphics. Okay, I am Ajita. That is looks fine, right? Am I Ajita is a question mark. Am Ajita I is also not perfect, which tells us this is known as your grammar of graphics, GG plots. We'll see it also. Okay, so that gives much more presentable manner. Okay, the presentation will be much more better. That is the only difference between GG plots and your plots. We'll see both. Don't worry, we'll see both. So first we'll get into univariate plots. Let's see what is univariate plots. Okay, so plot, we'll be using the function plot of. Plot of will be the function which will be used. It's very versatile, and it can produce different kinds of univariate. Single with one object, if you are able to do, that becomes your univariate. More than two objects, two and more than that, if you use, that becomes your multivariate. Okay, so first Sir, I want to share my screen.
You can share, ma'am.
Okay, so multiple. Okay. Okay. Really sorry, everybody. Like I have some network issues. I'm working in Chennai, but I came to my hometown for a during the lockdown. I'm stuck over here. So here in this village, there are some network issues. So really sorry for that. Okay. Now we'll work without. Okay. So we'll see how this x and y be plotted. Okay. So before that, first we'll finish what is univariate plots. That will be easy for you. Okay. So univariate plots is using one value for your plotting is known as your univariate plots. So you can use x value alone. Only one value you can use for your plotting, but provided you can also if you use two values x comma y, then it becomes your it becomes your automatically multivariate plots. Okay. So you can find here, we are only using one variable, x, that is known as your univariate plots. Okay. So here you can find, you can use bar plots to see your bar. Okay. This is a bar plot, bar chart. We tell it in, normally we tell this as bar chart, but here we tell it as bar plot. Okay. So you have to use your function bar plot where you have to write x. X is the variable, the single univariate variable. And you have to give you what is the space you require, how much space do you want that column to be, very small or very broad, what is it? Okay, that is known as your space. And then you have names.arg, which is specifies the vector of names to be used for the box. So for each of your name, what is that has to be given down, that is known as your names.arg. And you have your horizon, HORIZ, which specifies if the bars are horizontal or not. If it is horizontal, you can specify that. And you can also use your legend.text, which is nothing but specifies the vector of text used to construct the legend. Okay. So any text in the legend you require, then you have to give it. Okay. Then you have something known as beside, which specifies that the bars are staked or side by side. Does it come like, do you want to give a space? Does it want to remain side by side? That is known as your besides. Okay. And you also have your density or angle also, both are so more or less similar. Shading lines, it specifies the density and angle respectively. The shading lines, okay, the shading lines that has been available. And you have xlab. Xlab is nothing, the label which has to be given in the x-axis. And ylab tells you about your label that has to be given in the y-axis. And offset, which specifies the offset of the bars with respect to the x-axis. If you have some specific offsets has to be given, you can use it. And you also have CEX, sex dot names, or like it specifies the expansion factor of the bar labels. If you want to expand any of your bar names, bar labels, you can use it. Okay. So these are the things which are bar plots. See here. So when you give your spacing, based on your spacing, your space, your bar size varies. Okay. See here. So X is the variable and your Y space. And then you have your am I not audible? Is it not heard? Am I audible?
Audible, ma'am.
Okay. Somebody told I'm not audible. Okay. So like there we have main. Main is the title which has to be given. Can you see here? I have there the main has been given as gross horsepower. So automatically the title becomes gross horsepower. Okay. And you can find X lab. Lab is nothing but your label. So in the X axis we have something known as car. In the Y axis we have something known as HP. And the colors are rainbow colors has been given. 5 colors you are using because 5 boxes we have. And you specialize in it. Okay. So based on that your colors are varying. Okay. So that's known as your names and name.arg. Can you see it is given as spaced car 1 to 5 you wanted to paste, which means that car 1, car 2, car 3 up to car 5 will be available. Okay. That is known as your box plot. So this is how you will be seen. You can also give in your univariate plot, okay, bar plot, okay, that is your bar plots, right? So now you can use your univariate colors. Differentiation of colors can also be used. Okay. See here, there is a student who is known as Joe. So in class 1, you can find there are 3 marks. Joe's mark is there, Mary is there, Paula is there. So like 3 marks variation you have to show. Blue are Paula's mark, green is Mary's mark, and your Joe's mark is also available. Can you understand? So for these variations can also be shown in a bar plot. So don't worry. First, we'll see about your univariate plots. It's very interesting and easy. Okay, we'll use that first. So first, we'll go with your first one. Okay. We'll get into your R Studio. Okay. So from the very basics, we'll go. Okay. We have some data which is known as your Irish data. Okay. See here, it has been available. The name of the data is Irish. So whenever you want to show the data, what will you use? Always will use the word known as attach, which means after attaching, you can use the word automatically. So Irish is available. Okay, irish.com. Irish. So you have attached Irish. Irish is not found. So first you have to okay, so let's first import Irish. For importing Irish, first you have to use your Irish data. You have to use your what is it? Okay, let's go to the package and see where is Irish. We have given a search Irish data. What has happened to Irish data? Let me first give a search and see. Okay, search. Okay. I'm sorry. Irish is already existing. That is the reason why it didn't come. And I have whatever I have given I is caps. That is the one of the reason. It is already attached. Okay, so we do not want to attach it once more. When you want to view it, see I have given it as caps. That is the one of the mistake what I have done. See here, I can give a view. So view comes in the top space. Okay, so this is an existing data in your computer. Our program, I have told you about two types of data. Existing data are available. So there are data which have been automatically available within it. So you have Irish data. Now, if you give view in when you write view, V should be in caps. Once you write your view, V should be in caps. Once it is in caps, automatically you can view in the top table. Okay. See here, there is something known as sepal length, sepal width, petal length, and your petal width. We know about your, this is Irish tells about flowers. Okay, there are three types of flowers. One is known as setosa. Can you see there? This we tell it as species, versicolor, and last one is your virginica. So there are three species which has been used in this data: setosa, versicolor, and your virginica. So in this three, based on your sepal length, sepal width, petal length, and your petal width, it is easy for us to view what type of species does it belong. Okay, so now we'll see. Okay, we'll also plot this and see. Okay, I'll show you how to plot it. You can just okay. So I want it to be in the table. I'll copy this quotes. Okay, that will be easy for you. I'll send this coding file. Don't worry, that will be easy for you to enter. Okay, so it tells everything is wrong. Okay, no issues. Okay. So we use the table format. If you want it to be seen, view is the way in which you view your table in the above console, right? Above your console, whatever you see here is known as your view format. So we have told in our studio, there are four formats. One is your viewing, down is console, right side you will have your packages and everything. Above that you will have your environment, global environment. Okay. So here, even if you want to see, okay, let me show you in this format. I'll just minimize this. Okay, here even if you want to see, it becomes your table. Okay, table of, and what do you want to see? What do you want to see? I want to see in Irish. I want to see what are the species that is available. Inside a table, if you want to get each and every column, then you have to use your dollar symbol. Okay, so now I'm giving spaces. Can you see? There are 150 data. Out of the 150 data, setosa 50 data are available. Versicolor 50 is available. Virginica 50 is available. Can you understand? So out of your table, But setosa 50 is there, versicolor 50 is there, and virginica is also found to be 50. So 3 50s are available. Okay. So now let me do one thing. Let me plot it. Okay. So what should we plot for what? So before understanding even versicolor, let me go with your x and y axis. Then it will be easy for you. Okay. So first I'll finish that and I'll come over here. Okay. So let me use a vector to use it. So I have told what is Irish data. We'll finish. You will easily understand and then we'll come back. Okay. So here you can use the data. I have already done it. So what I'll do is I'll copy from there. Okay. Okay. So these are the variables I'm using, or these are the values I'm using in X. So let me see what is X. Okay, X is available. So now let me plot X and see. So how do you want it to plot? Just I have to give, this is what univariate. So I have to just give plot of X. Can you see it has been plotted here and there? It has been plotted. If you want different types to be plotted also, you can use it. So let me see here. I can give is equal to type is equal to within quotes VUO. See, it will get connected. Okay. Um, okay, it gets connected. I can also use something like your if I want to give some histogram, which I have to give. See here. If I want to use a staircase, then I have to use yes. In type, if I give, it gives me a staircase type of data. Okay, if the staircase has to be from above your uh, variables, then you have to see it's in the reverse format. You can, I hope you can understand. It comes here and this goes there. From where does it wants to start? Okay, so based on that, you can also do it. The line, if it wants to first start from your horizontal, then you have to use small s. If it wants to start from vertical and then a horizontal, then you have to give a capital S. So you can use all these types. I'll also show you something else also. X comma type of O I have given. I am giving you a label with some spaces. See here. So I'm telling that x-axis should have 20, y-axis should have 20, and then it should be separated by zeros. So automatically you can find here, previously you didn't have this, from 1 to 20 is available in your x-axis. Can you understand? So this is how your data can be plotted. This univariate plotting of your data. Okay. Univariately, we are plotting your data. So in univariate plotting also, we'll do one more thing. So see here, I'm asking it to take values randomly. See here, it has taken random values, random normal. So normal data, but it is found to be from normal where it is randomly it is taking 36 data has been taken randomly. Okay, it is taking randomly from data. So it's data should vary from it can vary somewhere until 10. It can vary from 0 until 10, and your significance level has been given as 5. This is the normal one in which it goes on. Okay, so x value is here. Now can I plot this? Yes, of course I can plot this. Plot. Can you see? Again, if you want to have some type, you have to give your type of. Can you see? The data has been plotted. Okay, now I'll also use this frequency, which is a very important one. I'm using a variable y provided this TS is nothing but time series. We use this word time series. TS is nothing but time series. Can you see here? When you once you give a what is it? Once you highlight it, it comes. Okay, and if you keep it nearby, it comes. What is TS? Okay, TS is nothing but your time series. So time series, it should start from X. X, you know, that previously we have given what is X from your random nominal. So R norm has been given and X is over there. So it starts Okay, it starts from here. Start C off. Okay, starts from here, C off. And here you can find from where to where does it wants to go. I want to go from the year 2010 and frequency should be 12 frequency should be there. 12 frequency, which means January, February, March, and all those are my frequencies. Let me check over here. Okay, see, can you see? It has started from 2010. It has started from 2010 and it has gone for 12 months. That is known as your frequency. Okay. And from X it has started. So automatically X, so the values which was found in X was taken over here. And based on that, we had all these values. We had 36 values. So automatically it has split it into 3 years. 2010, 2011 and 2012. Can you understand? So automatically it has split it into 3 years because we had 36 value. I hope you could remember the value of X. See here. 36 values are there. So these values has been put inside. These are the values which from which it has started. So time series started from X and start, see here, and from where do you want to start? From 2010 I want to start. So now like plot it. Okay. Plot of, okay, let me plot and see what happens when I'm plotting Y. Okay. So let me plot and see with different data types instead of X, let me give Y. Can you see? So now I have used here Y. Okay. Let me also try this. Let me give Y instead of X. Okay. Okay. So let me now give you the frequency. Okay. Let me change the frequency and see what happens. Previously, I have given the frequency as 12. Okay. If I give the frequency as 4, how does it take it? Because there are 36 values that you have to take into consideration. X has 36 values. See, can you see? So when you're giving it as 4, frequency is 4, for a year it will take only 4 values. So automatically 36 divided by 4 becomes your 9 years. So it splits from 2010 to 2018. Now you can plot and see how does your Y looks like. Okay. Plot Y. Can you see? So it has, you can see down from 2010 until 2019 has been 18 has been available. So plot X. So you can use this type. Okay. So all those are available with your univariate. All these are again univariate. Okay. So we'll use one more method with factors. Okay. See here, I'm using X as factor. Okay. I'm converting this as factor. We have seen what is a factor. Factor consists of levels. Do you remember? Anything which is unique will be shown. Okay. See here, I'm giving an enter. So now let me type what is X. It tells me this is my value which has been stored in X as factors. And the levels are 1, 2, 3. If I now ask ordered levels, it will tell me 1 is less than 2, 2 is less than 3. I hope you could remember factors. So that's how it has been. Now it is easy. 1, 2, 3 is being given. Now I can replace 1, 2, 3. How do I replace? I have a command known as levels, right? So level of X I can write. Okay, level of X. So I'm writing level of X has to be C of car, bus, and train. Okay, now let me type your X. Can you see? So once levels alone, I can change this 1 as car, 2 as bus, and 3 as train. Now let me give you X automatically. All this 1 has come as car. Okay, 2 as bus. Okay, 3. Next one is 3 as train. And again you have 1. So car. Okay, that's how it has got changed. Now let me plot this X. Okay, plot and see how this X looks like. Can you see now? Which is automatically it has become a how many times cars are there? Counter has been taken. It has put in the form of your histogram or your bar chart. Okay, I have not given bar chart. I only gave as usual as normally how we do. We gave your univariate plot, but it has taken in the form of your bar plots because of your number of times it has occurred. Okay. So let me now use your color for this. Okay, let me now use a color for this. Let me now use red color for this. Can you see? I can change the colors. Okay. It has to start with small letters. You can give your colors. Okay. Let me use, if you want blue, you can use. And there are variations in this blues also. I want aquamarine. Okay. Aquamarine. See here, this is the blue variations. Okay. This is somewhere like very copper sulfate blue and all those comes. Okay. So colors can be always changed. Okay. Now we'll see how to do your bar plots. Okay. So can you use your Irish data to plot your single univariate variable? Yes, of course, we can use it. But X and Y will be used. Okay, no issue. We'll use it 1 minute. Okay, first let me finish this and then I'll show you how to do your histogram using your Irish data. Okay, so now like we have plotted all this. So now the second what we want to see is, I hope you could remember, we have finished this, we have finished this too, and we have finished your plots using your bar plots, right? So now we'll get into your bar plots, how to get your bar plots. Okay, okay. I'll clear the screen. Okay, so let me give you a x value. Okay, this is the x value which I'm storing. Okay, x is your I'm using vector. It is 150, 200, 500, 350, and 125. So now if I plot this x, you can see how it looks like. This is how it looks. So if I use a type, okay, comma, type is equal to, if I use O, okay, so you can find this is how it looks. It connects. Okay, when you give your type of, it connects the data. That is the main importance of your type. Okay, so now I want a bar plot. So bar plot of, so we have seen what is the, it comes over here also, bar plot of, what do you want as a bar plot? I want x as a bar plot. Can you see? It has come, right? So your bar plot has come. Now I want to give all your what is it, variations. Okay, let me try all my variations. So I have, we have told what is bar plot. So bar plot of what is the data you want? It wants to be in x. Okay, then what else do you remember? We saw something known as your space. Okay, I want space between them is equal to 1. Okay, see, can you see? I can also change the spacings. 0.5, it varies. Okay, if I give 0.75, it varies. Okay, now I can give a color for this. For color I can just click on, okay, normally you can give a color. Okay, COL is equal to I can give for example aquamarine. See, but if I want to give different colors, then I have to use the function known as rainbow. Rainbow. Okay, so rainbow is equal to, okay, so what is rainbow? Rainbow should consist of, okay, sorry, color is equal to, color is equal to rainbow. And rainbow, how many rainbow colors do you want? I want here 5 colors. Okay, because 5 boxes are there. Okay, okay, then I have to specify my combinations also. So I can use my yes is equal to 0.6. I'm starting and like, can you see? If I change these numbers, what happens? We'll also see that. Don't worry. Instead of 75, I'll give it as 50 instead of. Can you see? It is dark. It is light. That is the main variation about this. Okay. Let me use something like instead of 6, I'll use 9. Okay. And instead of 75, let me use 90. Okay. Sorry, it is 0.9. So unfortunately, it has become 9. Okay. See here, it has become very bright. Can you understand the difference? Okay. This is little. Okay, this is very dull. 0.3 is very dull. 0.6 is normal. 0.9 is very bright. Okay, so that is the reason of your x and y. So there is no x labels and y labels. So let me use your labels and y labels. So inside this come your x lab. Okay, we tell it as x lab. In x labs, I'll use it as cars. Okay, and what is my y lab? Y lab. HPM. Okay, horsepower. So can you see HN Y has come. Let me use, I want some main heading to be available. Then I have to give a comma. Main is equal to, okay. gross horsepower and given enter. Can you see? Gross horsepower has come over there. See, O is a type which used to connect these points. That is a type. There are different types which have been given names, like S is for staircase, H is for histogram. And O is a type to connect all these points, which because you can see that whenever you give just a plot, you can find there are O's found over there. When you give type of O, it connects all the points. That is known as your O in your type. Okay. Okay, so can you see here? So I have given a main title, I have given a x-axis, I have given a y-axis. Now I can use this name cars, okay, car 1, car 2, car 3, car 4 for your each and everything. I hope you could remember that in your program, okay, which was given here. Do you remember? See here, names.arg is equal to paste of car. Very interesting. Only once you try one by one, you will understand. If you give as a whole, you will not understand what is the use of everything. Okay. So names. So here it comes. Names. As it is case sensitive, you have to be very clear on it. Okay. Names is equal to what is the name you acquire. I want it to be in the form of cars or car. Okay. And then what should come? Paste. Okay. I'm using a paste here because. Okay. So let me write over here. I want the paste is nothing but pasting two things. Okay, that is known as your paste. So inside your car, you have to paste. You have to give a comma because 1 to 5 has to be pasted. 1, 2, 3. It's not required that you have to write 1, 2, 3, and up to 5. And you want a separation. If you want a separation, leave it off. Otherwise, we have to take it. We'll see one by one. We'll just run this and see. See, can you see car 1, car 2, car 3, car 4, car 5. And there is a separation between each of your car and 1. I don't want that to happen. Then what should I do? Here you can write comma SCP. See here, now it has combined. Car 1 and car 2 has come very closely. Okay. Okay. So we have finished what was there. So I'll do one thing. I want these names to be different. I don't want these names to be in the form of car 1, car 2 and all those. I want it to be different. How do I want it? Car names has to be given. Then what will I do? I'll just take off this. Okay. In vector it should be. Let me tell my first car is Hyundai. Okay. And my second car is BMW. And my third car is Tata. And my fourth car is Maruti. Hyundai, Maruti, okay. And one maybe Kia Motors. Okay, let me now give an enter. Can you see it has changed? Okay. It has changed from Hyundai, BMW, Tata, Maruti, Kia. It has changed. And I can also give a change in your name. Can you see here? There is something known as name. Okay, I'll show you what is it. Okay. Okay, let me give an enter. What happened? Can you see the Hyundai BMW went so small? Okay, so that names it tells you about your size of the name that has been written over there. And let me give one. Okay, see here it has become very big. If you want to minimize it, you can also use it. Maybe like 0.75. Can you see it has gone small? So this is known as your bar plots. It looks nice, right? Like similar to that of what you can use in your Excel, you can also create it in R. Okay. So univariate, keep it very, very constant. We are using only one variable, univariate. Okay. So bar plots are available. So now, like, can I clear it? Are you clear? So control, I'll give you a control clearance. Okay, it has cleared. It has completely cleared. So now let me use the next one. We have used I hope you remember in single right in single three students in a single class. How did three students perform? That is known as your bar plot using your univariate plots using your single classroom. How did was the performance of three students? Okay, we'll see to this. So to create this data, first initially I want a matrix. This we tell it as plotting a matrix. Okay. So how do you create a matrix? Using your X and Y, you can create it. Okay. See here, I'll use this. I'll use this data. Okay. So X is equal to X is matrix of C of you have to give. And how many rows do you want this matrix to be? And this, if you are giving 3 rows, based on that, 3 into how much? Based on maybe it should be 3 into 3 is 9, so 3 threes are will come, or 3 into 3 4 is 12. It should be 12. Based on that, your data should be okay. Or if you want, you can also increase this. Here there are 12 datas. Let me increase this to. mm, Okay. So now let me see what is X. Can you see? So there are three students, 1, 2, 3, X becomes your rows, becomes your students, and 1, 2, 3, 4, 5 becomes your class. Okay. So now let me give you the names of your rows. Row names, let me give John, Paul, and Steve. Okay. Let me also use your, if you want, you can also use this X and C now. See here, 1, 2, 3 in the column remains the same, but the row has changed. Let me now give you a column name. Okay, column names. See, can you hear? You can just type 2, 3 words, automatically it comes. So what do you want? X of. So how should it be? Okay, let me give a different name. So algebra, geometry, history, I'll also add it as. So algebra, geometry, history, science, and physics are used. Can you see here? So class 1, class 2, class 3, class 4, class 5, the column names has been changed. And we have also changed the row names from John 1 to 3. It has already changed to John, Paul, and Steve. Okay. Now let's see how to plot this. Just give a plot of X. Let's see what happens. So it's only having this. So now what am I supposed to use? I'm supposed to use a bar plot, right? Because it's only bar plots will have this. So let me use a bar plot of X, because it has a matrix variable. See, can you see? Nice, right? So automatically it has taken its, what is it? Labels as algebra, geometry, history, science, and physics. But provided I want to give something more, there is no label for X. So let me give the label for X as X lab. Okay, X lab is equal to, it comes here. Okay, X lab is equal to, what do you want the name to be X lab? So I want it to be subjects. Okay. So let me try what comes out. See, subjects has come out. So now I also require Y. So what do you want? It is the scores of students. Okay. See, it has come. So now I require a main also, main heading to be. So it is nothing but main. Okay. So let me write score of the students subject wise. Let me type once more. Main is equal to, then quotes, score of the students hyphen subject wise. Can you see? Score of the subject wise. Okay, so now I want to put some colors over there. Okay, I want to put some colors. You can find, okay, let me, last time I have not used, we'll use this now. Beside. I don't want beside, so I'm making it as false. So let me see what is happening. You can also change your shape, sorry, change your size. Okay, so I can also give a color. Let me see, giving you a color. Okay, rainbow color. How many? It is asking me how much colors do you want? I'm telling it. It is based on 3 layers. So 3 I'm telling it. Can you see? 1, 2, 3. Okay. So now like whose mark is blue, whose mark is green, and whose mark is this I want, right? So that is known as your legend. Okay. So I am inserting here legend dot lab, right? Text. Okay. So now let me give not a graphical parameter. Right? Okay, small t has to be used. I have used a capital T. Now let me clear everything and come over here. The text should be in small t. There are 12 warnings. Use warnings to see them. Can you see? Steve, Paul, and John is there. It gives me some warnings. But anyway, it's been there. Okay. So I can use all this into it. So using one variation, this is a matrix form of doing it. Okay. Okay. So now let me go back to your Irish data, which we were seeing. I want to create a histogram with your Irish data. Okay. Let me show with one thing. Okay. I'm using one variable for it. So Irish, IRIS, and sepal length I have to use. So dollar sepal length. Let me give an enter. Can you see? So this is known as your histogram. Histogram format of doing your data is known as your histogram. Irish dollar sepal dot length. Histogram format. Okay. Now like okay, let me use one more thing and see the same but with colors and all those. Okay. See here, Irish dollar sepal dot width I'm taking, and I'm giving you a X label. I'm giving a main as well as I'm giving a color. Let me see how does it look. See here, it looks pucka, right? Nice histogram. Okay. So with this, your univariate is over. Let me get into your bivariate. Bivariate, from the word you can understand, using two things is known as your bivariate. Okay. So let me see what is there in your table. 50, 50, 50 is there. So let me have this in your consideration. Let me plot your length or your sepal length with your petal length. So anything that comes after hash will not be taken. This is for your understanding. Whatever you write first, left, okay, that becomes your y-axis. And whatever you write in the right side, that becomes your x-axis. Can you see? So petal length comes over here. Your sepal length comes over there. It takes that directly. See here, Irish dollar. So if you want to change, you have to give your X label, Y label, and then change it. Okay, so now this is like this versus this. For that versus, we'll use the symbol delta. We'll tell this symbol as delta. So we'll be using this delta symbol to show this versus that X comma Y, right? The same way Here, if you want to show bivariate is x comma y, right? So let's see what is x, what is y. Simply let's check. It becomes very clumsy, but anyway. Okay, see the length is not clear. Okay, okay, done. You can have x as okay, c of 1, comma 2, comma 3, comma 4, comma 5, comma 6. Okay, and I can also have okay, sorry, I should not have used your spare bracket. Okay, I can also use y. Y is like c of 2, 4, 6, 8, 10, and 12. Okay, now let me plot and see. This is known as bivariate. Two variables you are using. That is known as your bivariate. Okay, so here also I can use your type of, right? I can use your type of. So how do you use your type? Comma, type is equal to O. See, it connects by means of a line. If I do not want this O, I want only line, then I should give L. See, there will not be O's. If I want both, I should give B. Can you see? So I'll have line as well as B. The same way, if you want your staircase model, give S. Okay, if you want your histogram model, give H. So all these are available. Everywhere plot has all these variables in it to it. Okay. So now we had your setosa versus your right. Okay. The same way, let me try something else also with your colors and all those. Okay. See here. So Irish comes in sepal of length versus your petal of length, where very clearly it has been told that the Y label is found to be sepal length and X label is found to be petal length, and the main will be written as sepal versus petal. Okay, and if you want some type to be there, you can also give it, right? So let me give type is equal to L. See here, kachamuchang, kachamuchang. So what happened is all those points has been changed. Okay, so this is known as bivariate. You can also give colors for that. Let's see by giving some colors. Can you see? Okay, so I have given red color, and this PCH is the number which tells you about your shades. Let me change that and see. See? So depending on your number, there are many shapes within inside. So based on that, that will be changing. Yes, I'll send you the comment file also. I have it in the form of notepad. I have, for my practice, I have kept it in notepad. So I'll send this also. Okay, don't worry. I'll send two files today. One is this class file as well as your notepad file where you'll have all these comments. You can just copy paste and do it. Okay, I'll send it. Don't worry. I can type everything. It will take time. So that is the reason why I had a notepad. So I'll also send this document. Don't worry. Okay. So this is known as bivariate, plotting two things. We have plotted two things, right? Okay, done. So bivariate is okay. Univariate we have finished. We have finished univariate. We have finished bivariate. Okay. So now I'll also tell you box plot. Okay, box plot is something that is being done only when there is a categorical data and your you should have both categorical and your continuous data. Okay. So what is continuous data? Data is like 1, 2, 3, 4, 5. Okay. What is categorical?
మీరు మెయిల్ చూసుకోండి సార్ మీకు పంపించేసినాం ఆల్రెడీ లేదు వెళ్ళిపోయింది మీకు మెయిల్ అయితే వచ్చింది ఆల్రెడీ
Okay, so what is your categorical? Setosa, like species, Setosa, Virginica, versicolor, that is known as your categorical. Okay, let me plot and show you how to plot your box plot. Okay, so you should have continuous and your categorical. You can find your table of I hope it will be there. Table of Irish. Here it is. See here, sorry, table of Irish I asked, right? Okay. So let me use this Irish. Okay, table of Irish. Can you see? You have all this sort continuous data, provided only this species alone you can find. Setosa. Can you see? For everything. For Setosa, all that's been given 50 data. And here you can find Setosa, Virginica. Okay, only a few data has been given for you. Others data, see here, it has omitted this many of data. It cannot show everything for you. But somehow, this is how your continuous versus your so species here that's how you can use your box plot. Can you see here? So Setosa can find your mean in 5 and versicolor has its mean somewhere nearing to 5.75 somewhere and Virginica has it somewhere around 6.5. So you can find the difference. So in the x-axis you have species and in the y-axis you have, sorry, x-axis is species and in the y-axis you have your sepal length. So this is known as your box plot. Okay. You can also give names for your box plot, colors for your box plot. So bar plot is different, box plot is different. Okay. Can you see? I have changed your x-axis as species, y as sepal length, and your main is sepal length versus species, and your color is red. Okay. Okay. So now we'll get into your multivariate plots. So we'll use your multivariate plots. So I want your data to be very nominal as well as it should be randomly picked. Whenever you want that, we'll use this. Okay. So X is so X, let me give it as random nominal. It should be random as well as nominal 0 to 1. Okay. And Y again. From X it will take from 0, comma 1. Okay, and let me plot this X comma Y. Can you see you can get this normal curve? If you want this normal curve, then you have to use your data as normal data. That's the reason why we are seeing random normal data. From you can take any data, okay, provided how many number of data? 1,000. So 1,000, very small, minute, okay. From 0 to 1, it has to range, okay. And your, sorry, your mean should be 0 and your normal distribution should be of 1. So this is how it has been distributed, plots X comma Y. Okay, so let me now use your sequence of, I can use your sequence also. For your Y, I can use sequences. We have studied what is sequence. I hope you could remember it. So it starts from 1 until 5. It goes 0.55. Okay, that is known as your sequence. So there are two sequences I'm creating, X as well as Y. Okay, let me plot X and Y. See here. So the same way, if you want any types to be used, type is equal to both if I require B, right? So line and a O. Okay, there should be a comma where unfortunately it has been a dot. Okay, I have to use both and then only I can see this. See O is there. What is the problem? Plot X comma Y. Okay. Can you see? So both is there, X comma Y, and the type should be B. Okay. So this is multivariate, right? So I'll show how to use different data. There is a data known as plan growth. Okay, I'll show from there. Irish we have already used, so I'll use some other data. So these all are inbuilt data which comes along with your R. See here, there is a group as well, weight as well as there is a continuous data along with the group. So group there are control, TRT1, TRT2. So there are 3 data available in your plan growth. So now what I'll do is I'll plot this. Okay, group versus weight. I can also use a box plot because this is your continuous versus your categorical. Okay, so automatically it is a continuous versus categorical. So it has given 3 types of box plots. I have just given a plot, but it has given me box plot. Can you understand? So more than 2 and more than 2 becomes your multivariate, but I have shown very clearly about your this also. Okay, so let me show you one more data. There is a data known as rock. See here, this is the data of rock. What does it consist of? It consists of area, okay, a perimeter, shape, and your permanent square feet. Okay, so now let me use your plot for this. So plot of rock. Can you see? So this is like using all the possibilities. It has made a possible pictures for us. Provided you can find, it cannot read a very. It is not readable. This is known as your multivariate plots. Okay. So let me use some colors for this. Then I'll explain how to read this. Okay. Okay. As there is no third variable, colors will not be found. So it's okay. I'll first explain this. See here, this is area, this is perimeter, this is shape, and this is your permanent square feet. See here, if you read this data, you have to read like this is your x-axis, your perimeter is your x-axis, and your y-axis is your area. Here, if you read, it is like your perimeter. Okay, here all it is like the same. Okay, here you can find your perimeter. Okay, so when it comes over here, your x-axis becomes your shape and your y-axis become perimeter. Here, y-axis becomes shape and x-axis becomes your permanent data. Can you understand? So this is known as your multivariate way of doing your data. So we'll see this also. You can also do some calculations in your plot. See here, I'll show you. Okay. See here, I'm doing a data with, so this I have told you very clearly, this is delta. And between two datas, if you find delta, which means this is versus that. Okay, here I don't have it between, I have it in the first. Let me show you what happens and then I'll show you. See here, so it tells you very clearly, it has taken 3 datas. Using 3 data, the data has been found. Previously, it has taken all the data. Now it is only using 3 datas: rock area, rock perimeter, and your rock shape. Okay, only 3 variables has been taken into consideration. Now I want to have a x and it's different and your y is different. For example, I want to see area versus, see here, I want to see rock area versus rock perimeter, rock area versus rock shape. So once you give it, it will ask you, there are two columns that has to come. Okay, it should have come. You can find it. See, 2 things has come. If you want to see the previous one, you can use this. So can you see this is area versus perimeter and this is area versus shape. 2 diagrams has come. But I want this to be seen in the same screen. 2 diagrams I have used, area versus perimeter and area versus, to see go front and back, you can use this previous plot. See here, previous. Anything previous if you want, you can go forward, you can see if it is available over there. Until you don't clear it, it will be available. Okay. So now I want both to be in one single screen. I don't want it to be in a different screen. I want both to be in one single screen. Then I should use this comment. Okay. So what will I use? I'll use there is a column where C comma 2 comma 2, which means that there are 2 plots that has to be made. So after this, let me again Let me again use your previous one. See here, once I have used your parameters as your rows where I should have two columns. Now in the single diagram, I can see, or in a single page, I can see two things. Can you see area versus perimeter, area versus shape? Is that okay? So now we can see two things in one diagram, in one shape. Okay. So let me try with your okay Irish data. I can pair. There is something known as the pair concept. Let me try and show you. Okay, pair Irish from 1 is to see here. So sepal length, sepal width, petal, and petal width, everything joined together. I have asked it as a pair. So Irish data from 1 to 4. 1 to 4 is, I hope there are 5 things. Fifth one is species. We have not taken species. So it has started from 1 and it stopped till 4. So 1 is your sepal length, 2 is your sepal width, 3rd is your petal length, and 4th is your petal width. 5th one is species. Setosa, your versicolor, and your virginica. So we are not using that species. We are using only this. For that, you can use this known as pairs. Okay. I can also use this space with some colors into it. But there is some comment. See here, Irish from 1 to 4 I have to use. This is my shape or what I want. This is the color, red, blue, and green. I want it to be unclassed basis on the species I want it. Okay, this is known as your using multivariate. Can you see? Can you see there? So now you can very well understand what is this? What is this? Red becomes your, either it should be setosa or versicolor or your virginica. So I want that to be seen. Okay. And here, you can give your sepal dot is there. I want this to be given in the form of length. See petal length. Okay. See here. So petal dot has removed. Okay. Can you see? So automatically it becomes setosa is red. Okay. Your versicolor becomes blue and your virginica becomes your green. So it automatically has taken, okay, PG, red, blue, and green. So based on the iris species, first one will be setosa. So setosa, red will be assigned. Second one will be versicolor. So blue will be assigned for it, and virginica, green will be assigned. Okay, based on your numbering, how you have given, the numbers will be available. Okay, it looks good for presentation, right? This is known as your plotting, how you can plot it. Okay. Okay. So now we'll have your, as usual, next we'll see QQ plot. So before that, I'll clear your screen. So this is your, no, I have given the value of X. Okay, see here. So how many values are there? 1000 values are there. That is known as your 1000. So assign, randomly assign some 1000 values. That is your R random. Okay. So next, let me use your X. Okay. So let me now give you a Y value. Okay, let me try what is the value of Y. It should also be somewhere around 1000, but it should be separated. Each value should have a separation of 20. That is the meaning of this. Okay. So now let me give you a QQ plot of X comma Y. Can you see? It gives you a random from X and Y has been taken and randomly it has been plotted to give you a normal. Now I want this to be shown in the form of only one, but provided it should be neatly, very elaborately shown. There is only one. If it has many things, then the small thing is okay. So I don't have any other column, only one column I have. So now let me once more do it. You can see it becomes the entire screen has been fitted over that. This is purely been used parameters for fitting it. Okay. Now let me change your Y and then change your, based on that, let me change your Y is being separated by 1.5. Let me now change this. Now your 1 becomes, see, based on your values of y, your x and y has been plotted and different values have been got. So let me have this also. Y2. So now based on your Y2, I can also change this. Can you see? So this is known as your QQ plots. Okay, so these all are normal types of plots. So we have seen what is a univariate plot, what is a multivariate plot. And out of your multivariate plots, we have also seen what are your QQ plots and all those. See here, so multivariate plots gives you different densities. You have seen your L, O, S and all those plots. We have seen this. Okay, so we'll get into grammar of graphics, which is GG plots. Okay, so there is something known as GG plots. You have a separate package for GG plot. Okay, you can go to install also. You can give packages GG, automatically come. Okay, GG plot 2. Okay, this is like this is a multivariate multiple solution into one thing, and it gives a very good picturization for us to see it. That is known as GG. The full form for GG is grammar of graphics. Okay, so now it has been installed. If you want to use it, say it is not available in my system, so it is downloading from the internet. It's successfully unpacked and empty. Okay, it is now available. So how will I use it? I should use this library of GG plots 2. So now it is available for me to use it. If you have any other form, just click and unpack and packing it by means of a click, you can do it. Okay. So let me take your GG plot of Irish data. What happened? The following object is masking from empty cars. Okay. I've taken the data of Irish and I have given. You can only see a blank space because it does not know what to be taken in the x-axis and what to be taken in your y-axis. So now what do? I take a GG plot. Okay, I take a GG plot and I tell you it very clearly. I'm mapping it, telling that AES is the aesthetics. Okay, I can give many types of descriptions for it, where I'm telling X is sepal length and Y is petal length, and your inside both data should be there. Inside that, what should be inside is my species. Now you can find, can you see? Sepal length has come to the X and Y axis, it is petal length, and my column should be based on my species. But until I don't give, there is one more command which is known as geo point. It does not comes because only if I give that, it will be able to plot it. Okay, see here, can you see? So automatically it has taken setosa, versicolor, virginica. I have not given anything. I have only told column should be species based. It has to be given. So this is the difference between your normal univariate plottings and all those, or normal plot and GG plot. Okay, it gives you a much more picturization which can be used very nicely. Okay. I can also give shapes for this species. Okay. See here, different species, different colors. There is a round, there is a triangle, there is a rectangle. So different colors can be given. Okay. So this helps very fine. Okay. You want to give some histograms for some data. You can also use it. You can open some data from your local file, use it off. Okay. Let me show you that. I have a local from my space, from this space, I have a data on CSV. So this is the data. Okay, if you want to view the data, you can view it. V should be capital. And here I'm using house of. Okay, so can you see? This is the viewpoint of that. Now I'm plotting a graph. Okay, there is known as something known as pip. In R, we'll use this as pip, which is inside house. What do you want to select? That is known as pip. Okay, a dollar can be used the same way. Inside a huge data, if you want to take a small data, we use this. This is known as your percentage hyphen. This becomes your pip. Okay, this we tell this as pip. So inside house, select it. -1, which is like apart from your, if you don't want this first one, you can remove this. That is known as your -1. So apart from that, everything goes into house 1. You can do that if you want. Okay. If you want to select only few things. Okay. C of. Okay. I don't want your first one. Second one, third one, I don't want. I want only from the fourth one. So 4 is to, from 4, it has to start 1, 2, 3, 4, 5, 6, 7, 8. Balcony becomes 8, price become 9, and this become 10. Okay, from this I require, and this has to be stored in different variable, just house 1. You can do it. Select. Okay, to be installed, you want to install install the packages of, or it may be available, deployer. Okay, so let me now have a library of it. Okay, so no issues. We'll just use this to find what should I use for modeling functions that work with the. Okay, I'll check with that. Yesterday it was working. That was the reason why I thought I'll show you this split function also. So this is house. You can find like I have many data which I have viewed yesterday. Irish data. Yes. This house is there. House 1 I have created yesterday. Can you see? But I don't know why it's working today. Okay, no issues. Okay, we'll go with the remaining. I'll try why it is. I'll check it. It's only pip deployer and this should be there. So let me try. DPLYR. Yes. Okay, let me check now. Library has been available. Okay, see, it comes. Okay, super. Okay, only one issue is the library was not installed. Okay, it was not upload. We have installed, but I didn't do. I did this. I suppose I don't know why. What happened? Okay, sometimes it happens. Okay, see here. So let me use this. Okay, so from 4 until 10, I suppose. So let me see. So now house 1 is there. So let me view house 1. House 1 off. Can you see? It starts from size only. Is there? Can you see the difference? House starts from availability location size. It starts from house off. Okay. So you can use all this data for your ggplot. So let me show how to use this. I have to give. I have stored in the word known as house. So use this. So X I want to be the price and I want it to be in the form of histogram. Now I can give a enter. ggplot2. See here, it's all again, it has we have given, but I don't know what is happening. Okay. So let me use the histogram. See here, it has come. So based on price I have given, the data is, there is some fixed prices, I suppose. That's the reason why it shows like this. So now I want to give some colors to it. I can also give it. See here. So it gives some colors. Okay. I can also do your plotting with two variables can also be plotted. Let me show you that also. So here I have used two things which has not been available. That's what I see here. I have used something must fill air condition, which is like inside price. I want that air condition yes or no to be filled in. See here, I have used it. But provided there is no differentiation here, I can also use some other data. Let me check with this first. Instead of price, let me use some, what is the data you have? Let me use air condition. Let me check what comes for you. Instead of X, let me use this. Okay, it is not a continuous data. It tells me very clearly that it is not a continuous data. Okay, very good. So total square feet, let me use total underscore SQ SQRT of. Okay. TOTAL underscore SQRT. What happened? So each time this package something is happening. Data is house, mapping is there. X I want it to be okay. Plus geo. Yes, perfect. Then what? So then it will tell that there is no continuous data once more. Okay, let me try if I could see with bath. See here, because it only gives you about your down, it shows within 10, everything comes in. Right?
Ma'am, it's
Tell me the. Hello, tell me.
hello.
Yeah, tell
Ma'am,
me. Yeah. Can you hear?
ma'am, it is SQFT. You are trying
Okay,
RT.
okay. SQRT. Okay, so I can understand. Maybe that's rather okay. SQFT. Okay. SQFT. Now it comes, right? Okay, thank you so much. Okay, the value is very discrete. Perhaps you cannot have a count on it. That is the reason why it is unable to come. So for continuous data, usually it comes perfectly. Okay. So that's the reason why we had this data for price coming perfectly. Okay. Okay, so this is how ggplots can be used. You can use multiple things on ggplots. So with this, I'll stop with your plottings, okay, and I'll get into your modeling. Okay, so modeling is nothing. Purely modeling tells you about your all statistical things. How can you use is known as your modeling. Okay, so how to use your linear models, how to use your statistical things. Okay, all those creates your model. So before that, we were also seeing about this data wrangling yesterday, but somehow some few many of the what is it links were not working. So I found a link that is working for you. So this is known as murders.csv. So I have taken this as an URL. Okay, now I'm reading the file for you. So once I read the file, it is like read CSV of URL. Could not find underscore of CSV. Why? Okay. So read of read. Okay. See here, the file has come. This is a file I downloaded from your link. Okay, I'll show you once more. 1 minute, 1 minute. Okay, so I'll show you once more. See here, I have used a URL. So directly a URL from where I can save my data. That is very important. So yesterday's and all those days, what I was using, it was very old URLs where the data was not available. So now I have found a URL where the data is available. So URL is the place where I'm storing it. Now I'm reading in the form of your CSV. Can you see this is the data which I have downloaded? Okay. Okay. So now I want this to be stored in a local data. So it is, I have taken from I have only used a function name to store it. Otherwise it has not been stored over here. So what I'll use it is, if you want this to be downloaded in your local computer, then you have to use, okay. What you're supposed to use is the file name, the download.file. And what do you want, that URL, the file has been available and the name, okay. Maybe I want it in the name of murder because that was the name murders, okay. The existing file was there. So now like it comes into my local data. Downloaded 160 is 1684 bytes is there. So now let me read and see. Read.csv of, okay, what is the name of your file? Murders.csv. Okay. See here. So where is it? I can get my get WD working directory. You can, sorry, I have used this here. So the working directory tells me it is in documents. So from your URL, I have copied it and copied to the local computer. Okay. Now, if you, I do not want this file. Okay. I found that there is some mistake in this file. I do not want this file to happen. What I can do, I can also see here. I can also remove this file. Okay. See here, instead of A, it is murderers. Okay. So murders, I do not want this file, so I can also remove. Now I can try reading this file. Okay, reading, it will tell me that it cannot open because I have deleted the file. Can you understand? Okay, so from what did I do first? I'll show you once more. So I used an URL, okay, from where I can directly use my data. I use the word URL, that's the function name. I have taken this link into it. Now what do? To see what is there, I just made a reading of it. I found it. So better what I did was I want to store this in my local computer. So I use this download.file and the URL was being there and I gave a new file name which is known as murders.csv. Now it has been available. See here, download. It has downloaded in my documents. So I found that after usage and everything, I don't want it. If you do not want it, what you're supposed to do is you have to remove it. How will you remove? Just give a remove of file dot remove of. Once you give, that will be removed. Okay. I'll tell you one more way of exporting the data from your local computer. If you have some data from over here, And if you want to upload it somewhere, that also can be done. Okay, I'll show you. Table dot Irish. Okay, so I have to use table of Irish. Okay. So this is the table. So I want this to export. So we all this time we've seen how to import the data and store it in a local data. Now, well, let me show you how to export this data. Okay. So I have this data. Now what I do is I use the command known as sync. Okay. I use a command known as sync. Okay. I use the file name as Irish. Okay. And append this, whatever was above there, please append it and get it into this. See here, irish.txt is there. So let me now open this file and see. Read dot, to read your text files, we'll use delim. What is the file name? Irish.txt. No line available in input. Why, what happened? See, it has come. Okay. The only thing is I gave a control L to clear it, so it has not come. Otherwise, it is available. See here. Can you see the same things? What was there is available in my Irish. Okay. So anything you do over here, you want that. What is above that? If you want it, it's okay. So anything you have done here. So let me do it once more for you. See here. Table of. I'm using the table Irish. Now I'll use a different table. Maybe I used. Do you remember playground? Playground. Okay. Plant growth. Okay. Sorry. It was plant growth. Plant growth. Okay. So this is the table. I'm viewing the table. Okay. Now I want this table to be exported to my computer. So what do? I use this. Okay. Tell me what is the name in which you require it. So I use this again as plant. Okay. I'm using plant.txt. Append. What is in the above? Please do append it. That is what it is. Now see here. It has downloaded. Plant.txt is available. Now read.delim of plant.txt. And okay, I have to give it within quotes. No lines available in input. Okay. So one more time, let me try. Plant growth is there. So file is plant. It gets downloaded. Okay, let me read and see plant growth. So it tells me no lines available in input. Okay. We can also go to our local folder and find it. So it is in documents because that is the local area where I have stored all my data. See here, it has been found here. Plant. Okay, there is no data. That is the reason it tells me there is no data into it. Okay. So it has not appended. I don't know why it has not appended. Normally it appends. We saw how it appends in your Irish data, right? We'll see in Irish. Here. So here you have data, right? So sometimes maybe we have to refresh it. That's the only reason. Okay, it has come over there. So this is how you do data wrangling. We saw how to export from some other website towards our local computer and how to store it in a place. And we also saw existing data inside your R can be converted into your local computers. That also we have seen. Okay. You can also store all these images here, save as image, save as PDF. For you, anywhere you want to use in your journals and all those, directly you can save as image and you can do it. Anything comes over there, directly you can save. Okay. If you delete it once, it will not be available. That you have to be clear with. Okay. So now we'll get into your modeling. What is modeling? Modeling is the pure importance of R. So R is purely used for your modeling, right? Modeling is nothing. Using your statistics is known as your modeling. Okay. So how to use your statistics into it is known as your modeling. So let me show you how to do your modeling. Okay. So first is your descriptive. So we saw a few of this once more time. We'll see to it. Okay. So descriptive statistics tells you about your mean, quantile, okay, median, absolute deviation, variance, range, covariance, and your correlation. Everything can be got from your descriptive statistics. Okay. So let's see how to do it one by one. See here, it is mean of. If you want to find a mean of a class of marks and all those, give it as mean of and give the value of x where you will get your mean. Okay. And if you have to divide it into dimensions, you can do it. Always you can use the dimension of x to divide it into dimensions. Otherwise, you can leave your mean of. Okay. And then you have your quantile. Quantile tells about your percentage, right? So if you give your quantile as your see here, you can use it quantile of object. So object here is x comma and probs. Okay, where you have to tell it how you want to divide it. So sequentially from 0 to 1, 0.25 it should be divided. So it gives you in the form of 0, 25%, 50, 75, 100, or if you want 0.1, if you give it will give you 10, 20, 30. So depending on your percentage, it will give you. Okay, that is known as your quantile. So generally, it is a sample quantile of an object. And next, you have your Madoff. Madoff is nothing but it gives you about your absolute deviation. Okay, absolute deviation. Generally, we'll use like absolute alone. If you want to use, we'll use this ABS. So absolute of. You can use absolute of. If you get your minus values also, it will be converted into your positive value. That is the main work of your absolute. So once absolute works, then you can give your Madoff. Madoff gives you about your median absolute deviation. About in your absolute deviation, it will give you what is your median. That is known as your median absolute deviation. Then you have your variance, which is usually used to find the variance of a data type. From your mean, how much is it variated? That is known as your mean variance, right? So here you can find that your instead of giving these formulas and everything, directly you can give it as variance of. Automatically it comes. Range tells about your difference between your minimum and maximum. That is your range. And then you have your covariance. Covariance tells about your variance between two data sets, right? So x comma y, usually we require two things to find your covariance. So Pearson covariance is also available, okay, coefficient and those can be got over here. And correlation, it tells about when one variable changes, how does the other variable changes. So I have told you on that day, correlation ranges from -1 to 1. If it is between -1 to 0, which means it is negatively correlated. When one goes up, the other goes down. And again, if it is from 0 to 1, which is positively correlated, when one goes up, other also goes up. That is known as your positively correlated. So how much does it goes? That is known as your what is it? Correlation. Okay, so you can use all this in your descriptive. So this is your normal distribution. So first we'll finish your descriptive and come over here. So give some values for x. So let me give you x as in the form of vectors. Okay, so this is the value of x. Now, how can I find the mean of x? Mean of x. Right? It gives me the entire thing, add everything divided by the number of value. If you want to find the length of x, it is length of x. Just 20 values are there. So 20 values has been totally been added and divided by 20 gives you. If you want to find the mode of x, you can do. I hope this is just a revision of it. It's all numeric in format. Okay, type of x. This double we have seen. Okay, if you want to find is it a vector, you have to give is vector of. You give true because C of has been given, so it is vector. If you do not want, if you want to class it, you can class it. Class of x. It tells you numeric. You can also unclass. It gives you the entire number. Okay. So from this, we'll also file your quantile. Okay. Quantile of. So first, what is the data you want? It is x. Okay. So props. So how do you want it to be? It should be in a sequence. Start from 0 and it should reach 1. It should be divided by 0.25, just 25%. Okay. And then give like comma. The type is 7. Can you see? So 0, 25, 50, 7. So I can also change this. 0 to 1, it has to go. It is 0.1 basis. So you'll have 10, 20, 30, 40. Okay, let me also change this type and see. Okay, can you see? So exactly, it gives like when you give 5, it does not give you any decimal points in the middle and all those. See here, 2.8 becomes a round off value. Okay, that is known as your type. So how do you want it? So quantile we have seen. You can also find what is the median of x. Median is it will sort every of your value and tell you which is the center point. You can sort and see. Sort x, it tells you. So sorting tells me somewhere it comes between 10 and 11. So automatically it has taken the 2 number divided by 2, it gives you 10.5. Okay. Can you rank x? Yes. This is all we saw yesterday. Do you remember? Ranking can be done. Right? Okay. Now, what else do you want to do? We can also find the absolute. Okay. So absolute can be found by means of ABS. So if you want to find an absolute, first you should know your value should be divided minus from some number and there should be a negative. Then you will be able to. So let me do this. X minus mean of x. So it has the mean of x has been there. So out of that, I can just do a minus of. So everything is positive. So that is not required. So we'll do median of. Okay, median of x. And that is positive. Okay, absolute has been given. That's the reason why you are getting it as positive. Okay, I can understand. Sorry. See here, if I give like this, you will get negatives, right? Once you give absolute, everything turns into positive. Okay, and you can also find the range. Range we know, greatest is 25, smallest is 1, right? So range of x. See here, minimum is 1 and maximum is 25. If you want to find the variance of x, you can do it. So 56 is the variance of x. Okay, let me now, if you want to find the covariance and correlation, I require 2 variables. So let me give one more variable y. Okay, y. I'll give it in the form of vector. It ranges from 1 to 2. Or let me give from 49. And there I have given x. Okay. So let me find a covariance of x comma y. It tells me it is an incompatible dimension. Why is it so? Correlation of x comma y. Okay, let me change the value and go until 20. See, because x was found to have only 20 variables and y was very long, so it tells me it is incompatible. So let me find here correlation is found to be positive, which means that it is positively related. Whenever x increases, Y also increases. That is known as your positive correlation. It is a positive. So usually correlation ranges from -1 to 1. So this is 0.5, which is somewhere not so close to 1, but somewhere very greater than 0.5, which means that it is very, very positively correlated. If you want to find the covariance of x comma y, can also be got it. Okay. So these are the things which are descriptive statistics. So now we'll go with your probability. See here. So this we tell it as normal distribution. Okay. So in normal distribution, always your mu is your normal distribution is equal to 0. It will be the center point, and your standard deviation sigma will be 1. Okay. And we'll use this functions d of p of q of r of. That's what we were seeing, right? So p of d. I hope you remember r of random variable. So r of norm, r norm, d norm. That's what we were seeing. Okay. So in our probability distribution or evaluated by the following functions, we use d, and after that a name should be given function. So usually norm is the name which we are generally giving it. Okay. So function d of maybe we'll read it as d norm provides the probability density function. Okay, density function has been given d norms, and p norm tells you about your cumulative distributive function, and q tells you about your quantile function, and r tells you about your random variable that follows a probability. And xxx usually specifies the name of the distribution. Normal ones we'll use norm. Okay, t usually for students t experience, for t exponentials and all those we'll use. Okay, and data types can be numeric, integer, real numbers, and you can also use vectors, arrays, matrix, data frames, and all those. Okay, this is what we saw. We have used this normally everywhere. I hope you could remember. Okay, if you want, you will also try all this. Okay. So now, how to get your random nominal, how to get your what is it, quantile function, how to get your cumulative distributive, okay, and probability density function, on those can be found out. So everything has a similar formation. First one will be the number, okay, object, and mean, standard deviation, and your log of, which is nothing but your significance level. Okay. You can use all this. Poisson distribution is there, normal is there, log, normal, geometry, gamma, exponential. Okay. So first we'll finish this and come back to hypothesis testing. I'll show you. First we'll use this word. You will, maybe you didn't understand there, you'll understand here. Okay, let me have 1, 2, 4, 7, 5, 7, 7, 3, 2, 1. Okay. Okay, less than has come. Okay, it's my mistake. Okay. So now x value is there. Now let me find what is d norm. It tells about your probability density. So x comma, I'll use the x mean. Okay, let my mean should be 10, and my standard deviation should be 5. So tell me if this, based on this, give me a what is it, density. Okay, probability density function. So it gives me on this format. So once I have all this, my mean will be 10. For this data, my mean will be 10 and my standard deviation will be 5. Wherever I want, I can go and check this. That's the reason why it tells me, gives you my random probability. Randomly it gives me, provided it also gives in this format. Okay. I can also use the same to find your p norm of. So let me use your p. Okay. So let me store the above in a value known as q. So how do you store in a y? Okay, how do you store? I hope you remember. Dot last dot value. Okay, now let me substitute this q norm. There I'll use y, comma 10, comma 5. Use that data. Okay. So this is my q norm quantile. Okay, quantile gives you about your counts, 10% and all those. So now I can also use your random nominal. So 100, comma 10, comma 5. So I want 100 numbers where your mean should be 10 and my standard deviation should be 5. See here, I have got 100 numbers. Randomly it gives me. Okay. Now let me see what is my x. Okay. Let me check what is my y. I'll give. Okay. So the density norm. Take x. Okay. 10, comma 5. So let me check for these two variables. Let me plot and see. Plot x comma y. See here. If I want, I can give some type, comma type is equal to both. Can you see? Okay. So these are related with your probabilities. So probabilities is nothing but normally or you are randomly creating numbers on as your probabilities, random distribution, randomly distributing. Okay. So now we'll get into this hypothesis testing. These all are known as your modelings. Okay. Important modelings when it comes to R, statistical packages when it comes to R. Okay. I hope many of you would have heard about this word hypothesis. The best meaning for hypothesis is assumption. So anything whenever you do, we assume. Okay. For example, before testing something, what we do is we first assume and then test and we concluded telling that yes, it is perfect. Okay. For those assumptions, we'll have two assumptions. One is we tell it as hypothesis, null hypothesis. We'll represent it by H0. And next we'll tell it as alternative hypothesis. We'll represent it by HA. Okay. We'll represent it by HA. So we have null hypothesis as well as alternative hypothesis. For example, we tell that for example, I'm taking an apple, any apple whose weight is 0.25 grams, above that or equal to 0.25 grams is a best apple. This is my conclusion. This is my assumption. I'm just making an assumption. So anything that comes below or above is found to be a rejected piece, right? I don't accept it. Only anything 0.025 perfect, then I accept it. That's known as one sample t-test. I'm taking only one sample, one picturization, one condition into it. Okay, see here. So t-test can be used to either reject or accept your null hypothesis in favor of one. You should accept. Well, like you cannot accept everything, right? Either one should be accepted. So here we use this. Usually we use this form as H naught is equal to population mean is equal to mu. For example, here what I told is the apple, any apple which has 0.25 grams can be taken as your H naught, or you can use some mean of everything. So that becomes your population mean is equal to your sample mean that can be taken. And it can either be one-sided, which means one-sided is either it is greater than or less than becomes your one-sided, or it can be double-sided, not equal to this. Not equal to means either it can be less or it can be higher. That is known as your not equal to or double-sided. Okay. Then for using your t-test, you have to use the function known as t.testOf. If you're using t.testOf, it will be able. An object is a sample for which you want to conduct your test. An alternative is whether if it is one-sided or two-sided, you have to give you alternative. And mu usually specifies the true value of the population parameter and confidence level. Usually you have to give your confidence level. I hope you could remember this confidence level. You would have studied in your small classes. Whenever we studied your normal distribution, we have studied about it. There are two levels. One is your significant level. Another one is your confident level. Confident level is nothing but you are telling that 95% my data is correct or what I'm telling is correct. That is known as my confident level. And 5% you have an error, right? That is known as my significant level. 5%, 1% significant level, 5%. Normally only two things are accepted, 99 and your 95. So that's the reason we have written here as 0.95, which means that here they are using 95% confidence level. Okay. So using all this, you can always have your data. Let's see how to do your one sample t-test. Okay, let me take a data of xe1 by means of a vector. You can always define a x variable. If you want, you can use the same. They have used multiple data from here to there inside. Okay, let me also use the same. 1, 3, 5, 7, 2, 6, 5. Okay. So let this become my x. So let me take mean of x. What is the mean of x? It is 4.44. Okay. So this becomes my data. H naught is equal to population mean should be equal to mu. So 4.44 becomes my data. Okay. Let me now use my test of t dot test of. Okay. I'm making a test. So what is my hypothesis? Null hypothesis now becomes my population should be mean should be 4.44. Okay. Anything if it is goes below or above, then it becomes two-sided. If it is less than or small, greater than, it becomes one-sided. That should be noted down. Okay. So let me write. I'm using the data x. Okay. I'm using the data x. And what is the alternative? Either it can go here or there, small or down. So I'm giving it as two-sided. Okay. So two-sided. And then it is asking me what is your mu. Two-sided should have a dot. Okay. So what is your mu? Mu specify the true value of the population parameters. Okay. So here your mean is found to be 3.3. So here, right, population mean is 3.3. So they have given it as 3.3. So here for us, what is your mean? Our mean is 4.4. So let me give it as 4.4. Right. Okay. So what is my confidence level I have to give? So confidence level should be, I'm using, if it becomes a 99, it should be very accurate. So I'm giving it as 0.95. Let me check it. See here, it told me very clearly it is a one sample t test. My data was x. My t is found to be 0.09 and my degrees of freedom, it is the calculation value. P value is 0.92, which is much more greater. An alternative hypothesis, the true mean is not equal to 44. It tells me very clearly it is not equal to 44 because the mean of x is here. It ranges from 3.4 to, see here, 95% level. My mean ranges from 3.4 to 5.4. So I can always tell that my mean is not equal to 4.4. So I'll accept my alternative hypothesis, which told that this cannot be properly as your 4.44, right? Because my hypothesis tells very clearly a population should be equal to 4.44. No, it is not there, which means then I'll accept my alternative hypothesis, which tells that my population is either greater than not equal to 4.44 becomes my alternative. I'm accepting my alternate hypothesis. Okay. So let me use it over here. So next one, two sample t-test. So I have two samples from now I want to know whether the two samples came from the same population. For that I can use this two sample t-test. Okay. So H naught represents the null hypothesis and HA represents the alternative hypothesis. T-test can be used to either reject or not reject H naught in favor of H0. Okay. If there are two sample data sets, then this question comes, does it come from the same data type? Okay. So what can I do is, whenever I found that if it has come from the two samples has come from the same data set, okay, for example, from the same population I have taken a survey, which means that then both the mean should be equal to same. If both the means are same, then if I subtract both the mean, then it should be equal to 0. So H naught is equal to mu1. Mu1 is the mean of first sample, and mu2, which is the sample size of 2. So mu1, mu2. So okay, so there are two mean, mu1 and mu2. So always I have to make sure if both the means are equal, same, then automatically if I subtract from that, my answer will be 0. So I can accept that both has come from the same population. And second one is both, if I minus both of that, if it is not equal to 0, which means that it does not belongs to the same population. For example, we will use all this for surveys. Okay, hypotheses are mainly used for surveys. Mainly. We'll use everywhere. Every of our PhD thesis consists of hypothesis, but provided generally these type of hypotheses are being used for your surveys. Okay. So for example, I have collected from India many details. I have collected from Africa many details. Okay. For example, I should know that does this belongs to same India, which means that Indian population has it come from the same population? Many data have been collected here and there. So which means that if it has come from the same population, the mean should be same. The way they think, the way they do everything should be equal. That's the reason why mu1 should be equal to mu2. Okay. So the way how we use it again t test t dot tst only, but we'll have two objects. Okay, there is the only difference. So let me show you. See here. So first we'll have x and then we'll have y also. So now we'll find how to find your two samples. Okay. So data in t dot test we'll give x comma y. That is the only difference we'll have, and we can find it. So we'll give here. So x is available already. So now we'll give y also. Okay, so some y's are also available, but I don't think so. Length of x. Let me see. 27 variables. It's not available with y. If you want, I can give a random nominal of how much data should be there. It should be from 27 data should be there. Okay. Mean and standard deviation I want to give. Before that, let me find what is the mean of x. Okay, standard deviation of x. Let me give this and find it. Okay. See here you have 27 variables. Let me test it. Okay, I'll give a control so that t dot test of x comma y. So it tells me which two sample t-test has happened. Okay, and two difference in mean is not equal to 0. So both are not equal to 0, which means that I have to accept only my alternative hypothesis, which is not. Okay, see here. Here it is 1 x mean of x is 4.4, mean of y is 4.3. Here it is ranging from -1 to 1.4, which tells that both are not. If I does not belong to the same population, x is different value, maybe different set of people, and y is different set of people. It does not belong to the same population. Okay. So this is known as my two sample t-test. Now let me go with my. Okay, so next to two samplers, there is something known as KS test. KS test is nothing but Kolmogorov-Smirnov. We tell this name as Kolmogorov-Smirnov test. So it also has the same H0 as null hypothesis, alternative hypothesis there. If there are two sample data sets, two samples, then the question becomes whether the samples have been drawn from the same population, the same what we used. Okay, but provided data sets here we use t dot test. Instead of t dot test, we'll use ks dot test. Okay, this is a different method of doing it. The same, everything remains the same. Only one thing remains different is the method of doing it. Okay. See here. So ks dot. Only thing is we'll use ks dot. So we'll check both. Already we have a ks dot test. Okay. Of x comma y. What does it tell us? Two sample Kolmogorov-Smirnov test. Okay. Okay, let me change the value of y and c. First, the same comes because it tells you that very clearly the p-value cannot be computed, which means that hypothesis, the alternative hypothesis, two-sided should be taken and not the both the norm or your mean does not come from the same. That is the same meaning, the same of above, but provided the way it gives you is different. Okay. So next test is F test. Okay. So here H naught and HA does not differ anywhere. Okay. But provided we use F test can be done in the form of VAR, where of test. Whenever you want to do an F test to see whether it is doing or not. But here the F test, whenever you do, it does mean that it takes the standard deviation into consideration. Standard deviation of 1 divided by standard deviation of 2 should be equal to 1. That is the consideration in F test. Okay. So let's check this. So what will you give? Var dot test of var dot test of x comma y. So here it will take consideration of sigma 1 divided by sigma 2. Okay, it varies from 0.4 to 0. So which means that null hypothesis will not be accepted. Okay, so null hypothesis will not be accepted. These tests you can try it. What is chi-square test, Saprio test, Wilcox test? You can try. Okay. So now we'll get into your linear models. So you know about linear modeling. I do hope that everybody knows what is linear modeling. So usually we'll have this, right? Y is equal to B naught plus B1 into X1 plus B2 into X2, right? That is the normal format in which your linear models are being found, okay? So linear models usually will find how much factors affects a single factor. That's where your linear regressions, linear models comes into consideration, okay? So y becomes your dependent variable and b your x1, x2 becomes your independent variable and b0, b1, b2 becomes the factors that influence the dependent variable. That is known as your b0, b0 or your beta. We can tell it as beta, beta 0, beta 1, beta 2. Okay. So here you will have different operators. We can use minus, okay, you know it is for subtraction multiplications. But here we'll use it for different thing, okay? So when we use this y versus x1, that is the meaning when you use this delta function, okay? So star has been used to find that these are the factors that are affecting, used for multiplications and all those. So there are multiple linear models available. You have all these formulas available. Okay, this is only models of formulas. Any type of formulas can be got. Whenever you tell x1 plus x2 plus x3 raised to 2, this is the formula we have studied in our small classes, x1 plus x2 plus x3 plus x1 into x2 plus x1 into x3. So all these have been available. Can use your all this. See, these are the linear models that have been available with simple linear regressions. Classification analysis are there, regressions with weights. Okay, so any of this you can use it. Okay, you can use any of this. Okay, this will be used only when you're using a linear regressions and all those. That's it. Okay. So let me give this y. I'll take this as my constant. Okay. X1 into X2. See here, it has come in your global environment. I hope you can see this global environment. See here, the last one. Okay, let me find terms of y. See here, it told me what is my y, what is my attributes, what are my list, how will it take into consideration x1, x2, x1 into x2. All the values are there. Okay, when you use a linear regression, if you have some formulas, you can directly give over here and you can use it. So R is used very clearly for doing all this. Okay, you can use any other formulas you have also, you can use it. Let me give you one more formula. Delta of, sorry, here, small y delta of x1 plus x2 plus x1 and x2 terms of y. So it has given you, okay. So any type of linear regressions if you have, you can always use it. Okay. So how will we use this linear models in our computation? Because we don't understand all this. It's very vague. Okay. So let me show you in our programming, we have some data there. How will you use it? To use linear model, you have to use the word LM. Okay. If you use LM, you can understand that is known as your linear modeling. Okay. So let me show you how to use your linear modeling. So the function LM is maybe used to generate a linear model. So usually it tells you about your formula. Initially there should be a formula and then a data, weight and subsets. These are the, this has to be given in your prompt command. And parameter weight is to, the weight is nothing but it specifies the optional vector of weights. That is your beta 0, beta 1 we saw, right? That's up. So the parameter subset tells about your optional which specifies a subset of a data. Okay. So don't worry about all this. We'll see to it. Okay. I'll tell you how to do it. So I have the comment. You can use the same comment. Okay. So after your G plot, you have something known as linear model. You can use this. There is an existing model which has been available in the form of, we tell that in the form of empty cars. Okay. See here, empty cars. So if you want to view what is there, V should be caps, views of empty cars. This is a data set that has been inbuiltly available in our view, right? I'm sorry, I have used views. Okay. See, it tells you about MPG, CYL, dispenser, your horsepower, okay, your weight, Q-sec, and everything has been given. Okay, it is related with your motors, okay, cars. Okay, done. So let me know what is that. If you want to find a linear model, first what I supposed to do, you have to first make a linear equation. Okay, that is very important. Directly also you can use it, but we'll also use this. Okay, see here how have I created my equation, you will understand. Okay, see what am I used? I have used MPG, this is a constant, and then CYL plus dispense into H power into weight. Altogether, this gets into MTS car. So this is the equation. These are the variables I'm taking into consideration. Okay, so give an enter. So now I'm using my LM. What is LM? LM is the linear model. I'm creating a linear model for this data. Okay, so this is from which data? Empty cars I have to take. So empty car form is the formula. These are the variables that has to be extracted from there. So I'm using LM. So automatically a linear model has been created. I want to see, right, what is there in the linear form. So let me see, cars of LM. Okay. So can you see here? We are studying now small classes. Do you remember intercept, which is the constant? And for CYL, this becomes minus 1.29 becomes your B naught, which is your, we tell this as your, your CYL becomes your dependent variable and minus 1.2 is the factor that is affecting the dependent variable. Okay. So this becomes your coefficient, intercepts, CYL, dispense, HP and WT. Okay. Okay. So if you want to find what type of data is it, you can find always, you can have this word as type of. So type of, so I just keep my cursor over there, type of, and then my, empty cars underscore LM. Okay, it is a list. It has been stored in the form of a list. So you want to find the class of empty cars. Okay, it shows over here. Okay, you can show. So it is a linear model. In the class, it has been found to be in the form of linear model. So I do not want that. So I'll unclass empty cars of LM. So once I unclass, it will be showing for having in the form of your pure data. Okay. So this is how your unclassing and everything happens. Let's check what are the names which have been available over there. So it tells me like coefficient, residuals, effects, rank, fitted value, assigns, all these are there in my linear regression. Okay, in my linear regression, I can find all this. So I want to find all the coefficients alone. I can do this. Okay. I want to find only the residuals, which was each and every variable. Can you see here? So from there only I'm taking. So if you want to find your residuals, you can find it over here. If you want to find only the fitted value, you can do it like this. What is happening? Fitted dot value. Okay. So up you can find how it has been shown. You can use that. Okay. As a general, I want to see what is the summary of it. Okay. Summary of empty cars dot lm. Okay. Sorry. Okay. So it tells about your minimum, median, what is the intercept. For the formula, what I have created alone only, it will tell me there are much more variables. It will not show it. Okay. Apart from that, you can also give coefficient of, it will give you. Okay. There is something known as ANOVA. Okay. If you want to find the ANOVA of it, it will also give you analysis of variance table. So how much degrees of freedom is there, minimum square, F and may R square, residual value. It will all give you. This formula is not fitting into, you can also change your formula. Okay. Okay. So now we'll get into your tree model. So I hope linear is more than enough with this. Okay, we'll get into your tree model, which is a very interesting model, which will help you in finding all those. Okay, tree model, how to get your data in a tree format. Okay, so we know the data which we have used is your what is it? Irish data. We'll use the Irish data, and here R part is the function which participation. Okay, R part, the full meaning is recursive participation. Again and again participating is known as your recursive participation. In tree model, we'll use the format known as your R part, where you should give your data, weights and subsets. Okay, as normal we'll be giving. Okay, I'll tell you how to do this. Don't worry. It's very easy. You have some data, and if you want to divide it in the form of tree, you will understand this. Okay. Okay. So first we have Irish data, I suppose. If you want, I can also check it and show. Search of. Once you give your search of, it will show you if you, yes. Is Irish data available? So it's not available. So let me attach. Attach Irish. Okay, let me give an enter. So next I'm giving a search. Yes, now Irish is available. Okay, so now let me use your Irish data. Okay, so if you want to know what is R part, you can also give question mark R part of. Okay, C tells you it should have a formula, data, weight, subset of everything should be there. Okay, okay. So let me use this as you are very familiar now with the Irish data, let me use this. I'm using Irish of form as the function which. So species I have taken it as intercept or my constant, and I'm adding all the other things. Length, width of your sepals and your petals. This is the formula which I'm using. So now I can put this formula in my Irish. So I'm using this word Irish tree I'm using. Okay. So see here, R part Irish dot form, comma Irish. Okay. Could not find R part. Okay. Then what I should do is I should now search for R part and install it. See, it has not been included. So now, okay, now I can do it. Okay. Once that has come, now I can do this. See here, now there is no error which is coming out. Okay. So let me now see what is Irish part, Irish.tree. Can you see? It has divided itself in the form of your parts. Okay, tree formats. Where then 1.7 and 1.75 has been taken. Let me see how does it looks in the form of your summary. Okay, summary of Irish so it gives me many summary, may not be, I don't want all this. If I'm going very specific about my data, then I require it. So what I'll do is now I'll go with my see here, I'm using Irish data only. So Irish form, comma Irish. Now I'm using a control over there. So let me, I'll show you, then I will understand. Okay, let me now plot Irish Irish.tree. Okay, see here. Okay, so I'll give you some text also. It is very small. Why is it very small? So I want only that to be fitted inside. If I want only that to be fitted inside, what should I do? I hope you could remember. It is PAR of mfro see, it has come because only that should be fitted inside. So you can directly give this. Now I'm giving the names also. I'll just divide this. Okay. Can you see? It is Setosa. I don't know why what happened. So generally, okay, I'll once more time I'll give this. Okay, Irish plot of. So see here, it has plotted. So I want the names to be there. So I'll give you text of. See here, it has come perfectly. See here. So less than 2.45, it is Setosa. Greater than, then if it is greater, it goes over there. There it again checks it is less than 1.75. There it has two divisions of petal length is less than 4.95 here and there. Okay. Virginica, Versiticoca, tree type. It has given me as the tree type of data. I want only 5 buckets. I don't want much to be there. Okay. Then what I can do is I can give minimum bucket as 5, which means I'll only have directly 5. Now I can plot and see. See 1, 2, 3, 4, 5. Okay. So now I can use this. See here. It gives a symbolization. It does not gives you a very clumsy data, very simple data. Okay. Then you have to use the word known as minimum bucket. This is known as your modeling in R. Okay. So you can use, there are many things available. You can also use all those. Okay. Where we have used, I have told you how to model by means of your descriptive statistics. We have used distribution. We have seen how to see your hypothesis testing. We have seen your linear models, and last we have also seen your tree model. Okay, these are the basic things. So once you're familiar with R, you can also go with your advanced things. Okay. So thank you so much. So for being with me for all this 5 days, thank you so much for bearing with me. Sometimes I had some network issues also. So you're bad with me for very, very badly were with me. So thank you so much. So Prasad sir, you're there? Hello. I'll send all my documents, this comments and everything what I have, I'll send it, okay? So anything else you want to ask, please do ask me. You can. See, usually we don't use R with codings and everything. We only show the output in the forms of plots, in the forms of, as we shown, like datas, okay? That is where R is very famous for.
Ma'am, how do we save this? If we're working in our console, how will we save? Like when we open, if we suppose today I have worked on it and tomorrow
Yeah,
again I want to open it, then
there's only one thing I have told previously. I have told you, like go to your file, or below that there will be a plus symbol which tells about create a project. Okay, or you can go to file and tell it as new project, and you can store it daily. You can store it over there.
how will we store it, ma'am? Like any specific this one, or just it will
So
be stored?
you get into file and give it as new project. It will
Okay.
automatically get stored in your R. There is a database, or there is a folder for R where every data gets into. For me, it is inside C folder documents. There it gets stored. Okay, if you want, I'll show you. Wait. Can you see this is my R, right? So here I have a plus symbol. Either I can use that or I can go to file. So I'm using this plus symbol. It asks me whether for it's a new save the project. Yes, I want to save. It shows in the form of data. Okay. Do you want to create a new directory? No, I want the existing directory. So it is asking if you want to browse something to browse. If you want a specific space, you can browse it. I don't have anything, so just I'm leaving it and I'm giving a create project. So automatically all the comments get saved over there. Anytime you want, you can just open it. Okay, I'll also show you where it gets saved. See here, it comes in the form of our project, our data, our user. This is our data. If I want to open, it will show me whatever I have done will be available over there. Do you want that come everything inside? It's asking. Yes, if I give, everything will be downloaded. So anytime I can use the Irish empty car form, URL, XY, set everything. Is that okay?
Okay, ma'am. Thank you so much.
Okay, okay. uh, R is very in-depthly, it has been concentrating only on statistics. That is a drawback of R. Where Python, now everything what has been available in R has come in Python. They also have multiple things. That is the only feedback. There is no drawback in R. There are still companies which are using only R. Hereafter, they have to shift towards your Python. Okay, today if you go to many of your fintech companies and your analytical companies, maximum they are using only R. So I don't find there is no limitations. One thing is R is more concentrating only on statistics, where Python is not on only on statistics. It's on all the parts of the world. It's like a king of everything. This is like a queen of statistics. That is the only thing. Thank you, Kiran. I hope you were there with my from the day one. Like few of your names, like Kiran. Uh, it's more or less same, Kiran. It is more or less same. Only few like features are different from there and here. Otherwise, it is more or less same. Thank you. So Prasad sir, you're there. So where did you get some insights into it? R can be only being created only if you. Sure, sure. You can always contact me for further queries. Okay, I'll give my mail ID. Uh, I have. You can contact me in my personal mail ID also, or I'll also give my official mail ID, my college mail ID. So always my personal. Both are available. Anytime if you have any query, please do send me. You can email me, I'll respond to you. Okay. So these are my mail IDs and my phone numbers are available. Please do respond. Anything, any query, you can always come over there. Okay. Prasad sir, can I wind up the function, wind up the program?
Yeah, yes, ma'am.
Okay, sir. Anything else you want to ask me, any doubts? Because this purely R is like modeling. If you see, there are many modelings which are available. I only taught you 5 modelings because once you go with your linear modeling or hypothesis or your descriptive, that's where we'll be using more amount of this. Okay. So use it. I'll send today's file also. Anything else, please let me know. So thank you, everybody. Thank you, participants. Thank you so much.
Yeah, thank you, madam. Thank you very much for giving this time for us. We are happy to see you in the next sessions also.
Thank you, sir.
Upcoming
Thank you so much,
sessions.
sir.
If any doubts regarding about our anybody contact freely to ma'am, no problem. Ma'am is also interacting is a good manner, no problem, not a issue. If anybody want to talk regarding these sessions, you can talk, no issue. Don't have any queries. I think so. Everyone understood every point and madam, no issue. Thank you, madam. Thank you
Thank
very
you,
much.
sir. Thank you so much. Thank you, participants. Thank you so much. Thank you, sir. Thank you so much.
Thank you.